Welcome to today's lesson on the rate of photosynthesis, where we will explore the meaning of inverse proportion and its application through the inverse square law of light intensity in the context of photosynthesis. Today, we will first understand what inverse proportion means in a scientific context. Following that, we will delve into the inverse square law to see how light intensity affects the rate of photosynthesis. This will involve some basic mathematical concepts which we will go through step by step. So far, you have learned that light intensity is a critical limiting factor in determining the rate of photosynthesis. Without sufficient light, plants cannot photosynthesize efficiently, which limits their growth and productivity. Understanding the concept of inverse proportion and the inverse square law allows us to get a deeper insight into the role of light in photosynthesis. This knowledge will enable you to appreciate the delicate balancing act plants perform to optimize their growth conditions. By understanding these principles, we can better manipulate agricultural practices to improve crop yields and manage natural ecosystems more effectively. Let's get started. Inverse proportion describes a relationship where one quantity increases while the other decreases. One of the most crucial applications of inverse proportion in biology is through the inverse square law. This law specifically relates to how light intensity diminishes as the distance from a light source increases. The formula can be expressed as light intensity is proportional to 1 over the distance from the light source squared. To put it simply, if you double the distance between a light source and a plant, the light intensity that reaches the plant decreases to 1/4 of its original intensity. Let's go through an example to clarify this. Suppose you have a light source that is 1 meter away from a plant. The light intensity at this distance is quite high. However, if you move the light source to 4 meters away, the light intensity would be 1 over 4 squared, or 1/16th, as intense. This shows that distance significantly reduces the amount of light that reaches the plant and how much it receives for photosynthesis. As the distance between the light source and the plant increases, the light intensity decreases, and thus less light energy is available for the chlorophyll in plant cells. This results in a slower rate of photosynthesis. Conversely, when the light source is closer, the plant receives more light, and the rate of photosynthesis is higher. Understanding this inverse relationship is critical in practical applications. For example, in greenhouses and other indoor farming, plant light exposure can be optimized by adjusting the placement of artificial lights, ensuring plants get adequate light to maximize photosynthesis. Let's work through some questions to consolidate our understanding of inverse proportion and the reverse square law in photosynthesis. Question 1. A plant initially receives light at an intensity of 100 lux at a distance of 1 meter. What light intensity will the plant receive at 2 meters? And how might this affect the rate of photosynthesis? Pause here to have a go. Now let's walk through the answer. Firstly, you must identify the relationship. Given the inverse square law, light intensity is inversely related to the square of the distance. Now, starting with initial conditions, at 1 meter, the light intensity is 100 lux. Now we can calculate for the new distance. At 2 meters, the light intensity will be 100 lux multiplied by 1/2 squared, which equals 100 times 1/4, which is 25 lux. Now we can relate this to photosynthesis. Photosynthesis rate generally increases with light intensity up to a certain point. With intensity dropped to 25 lux, which is 1/4 of the original, the rate of photosynthesis would likely decrease significantly. In conclusion, at 2 meters, the plant receives 25 lux, and this lower intensity would cause a considerable decrease in the rate of photosynthesis. Now for our second question, at a distance of 5 meters from a light source, a plant receives 8 lux of light intensity. Calculate the original light intensity of the light source. Pause here to have a go. Now let's walk through the answer. Firstly, you must identify the relationship. Given the inverse square law, light intensity is inversely related to the square of the distance from the light source. Find the proportion of the original light intensity the plant receives at 5 meters away. At 5 meters, the light intensity will be 1/5 squared, which equals 1/25 of its original value. Find the original value of light intensity. 8 lux is 1/25 of the original light intensity. Therefore, the light intensity of the light source equals 8 times 25 equals 200 lux. To answer this style of exam questions, make sure to remember how to use the inverse square law and its importance in the context of photosynthesis. In today's lesson, we examine the concept of inverse proportion and its application in the context of photosynthesis, specifically through the reverse square law of light intensity. We began by understanding that in inverse proportion, as one quantity increases, the other decreases. We then looked at a specific example of this in the inverse square law. This relationship is fundamental in many biological processes, including photosynthesis, where light intensity plays a crucial role. This law is significant because it explains how light energy diminishes with distance, impacting the rate of photosynthesis in plants. We also considered the practical applications of this law in indoor farming and greenhouses. By understanding the principles of inverse proportion and the reverse square law, you now have a deeper understanding of the factors that affect the rate of photosynthesis. This knowledge is essential for studying plant biology and the broader field of bioenergetics, impacting both ecological studies and agricultural practices.